Okay, so it appears that my board closed down and I perhaps lost the first part of this video, so we'll try to remedy that problem. We had gone over the previous day's notes, and now we're starting to go over new notes where we finished yesterday. So we're going to start here again with linear and angular speed. Linear speed measures how fast a particle moves. Angular speed is how fast the angle changes. Linear speed would be the speed a person runs around a circular track. Angular speed would be how fast you would have to turn a camera set in the middle of the track to keep taking a video of the person running around the track. Linear speed is arc length over time. Arc length is radius times theta. So linear speed could also be written r times theta over t. Angular speed is simply the central angle, or theta, over time. All right, so the second hand of a clock is 12.2 centimeters long. Find the linear speed of the second hand. We draw a picture seeing that a radius is 10.2. Write out your formula, write out all your variables, and come up with values for them. Since it's a clock, we're going to consider going all the way around, which would be an angle of 2 pi and would take us 60 seconds. So linear speed is 10.2 times 2 pi over 60, or 20.4 pi over 60. And because we never talk about driving our car at 20.4 pi over 60, because of context, we're going to actually multiply this out. Anytime we multiply using pi, our answer is an approximation. It is not exact. So when we have an approximation, we want to come in and use these two squiggly lines instead of an equal sign. That tells me it's an approximate. And if we multiplied this out, it would be approximately 75.4 inches per second. That is wrong. I'm looking at the wrong thing on my sheet. If we multiply that out, and we actually did it correctly, we would get 1.068 inches per second. Okay? Okay. A lawn roller with 10-inch radius makes 1.2 revolutions per second. So we have a lawn roller. Why did it change? I have a board that's kind of crazy. It's a John Deere lawnmower. And we're going to pull this lawnmower. And what we know is that the roller has a 10-inch radius. So this radius here, R equals 10 inches. We know it makes 1.2 revolutions per second. What would theta be? We want to find the angular speed equals theta over time. So I need to know what theta is and what time is. What's my time? How many seconds are we talking about here if I did 1.2 revolutions per second? Per how many seconds? Per second. 1 second times 1 second. Okay? Now what's my theta? What's 1 revolution? 1 revolution is 2 pi. How many revolutions did I do? So am I going to multiply 2 pi by 1.2? Yes. Times 1.2. So theta equals 2.4 pi. We will not multiply by pi until the very end if we do it then. Okay? So do I have theta now? Do I have time? So I can plug this in and know that our angular speed is 2.4 pi radians per 1 second, which we could write 2.4 pi per second. Radians per second. Okay? Now we need to do linear speed. Linear speed is arc length divided by time, which equals radius times theta in radians divided by time, which equals, my radius is 10 times theta, which is 2.4 pi, all divided by 1 second. And so that equals approximately 75.4 inches per second. Okay, let's talk about quadrants for a second. Everybody got that? Okay. Over here in the top right, which quadrant? Top left. Bottom left. And the bottom right? 4. In quadrant 1, what are the signs of my X and Y? Positive, positive. In quadrant 2. 3.
Negative.
4.
Positive, negative.
All right, it's very important that you got that piece down. All right.
Look like some faces.
Yeah.
Some eyes and a nose. He looks fed up. Quadrant 2 weekend with the bright
So is
eye.
4. Yeah. All right. Over here on the right, on the X, this is where we start, correct? So this is 0 degrees. How many degrees is straight up? 90 degrees. Next, these lines are quadrantal lines. They separate the quadrants, so they're quadrantal lines. On the quadrantal line to the left, how many degrees? 180 degrees. Down 270 degrees, and back where I started, 360 degrees. Let's do radians. How many radians is it where I start? Where I start? 0. Now, where I start, it's 0. If I'm starting here and I haven't been anywhere, it's 0. And that's important, okay? Yes, Julie, yes, 2 pi is the same place. But 2 pi's mean I've been all the way around the circle, but I haven't done anything yet. So what is it with 90 degrees? Pi over 2 radians. What it is at 180? Pi. What is it at 270? 3 pi over 2, and back at 360, 2 pi. Apple and sweet potato, that'd be great. 2 pies.
I like apple and sweet potato too. I hate coconut pie.
Oh, can't handle coconut pie.
Buttermilk pie is good though.
Who?
Buttermilk.
Buttermilk pie is nothing I've heard of or tried and does not sound appealing.
It is though.
Alright.
It's good.
Alright, everybody get your quadrants. So tell me, where is 45 degrees? Which quadrant?
And 1.
1. What's 3 pi over 4?
It would be in 4.
No.
No, it'd be 4.
3 pi over 4. What's pi in terms of force? All right, pi is equal to 4 pi over 4, right? Pi over 2 is equal to 2 pi over 4, correct? So where would 3 pi over 4 be? Which quadrant? 2. Okay? All right. Let's see if we can do for homework. Come on, board. Uh-oh. Homework, this is 4.1. Let's do 23 through 51 odd. Be sure to check your answers in the back of the book, and if you don't get them, try to figure out where you made your mistake. Check with Khan Academy, check with your friends. Y'all set up a group chat or whatever you need to try to work it out, and we'll go over those tomorrow. Answer questions for those that you're uncomfortable with. All righty.